Hello, all you Algebra 2 scholars. We're back. I'm going to do one more video for this instruction part. It's going to take us a number of days to go through it. I hope if you're home, you're following these along. Again, write these down. These are your examples. What we're going to do in section 4.4 is we're going to factor completely. And whenever you see the word completely, that means you're factoring more than once. Okay, so you'll factor something, either a GCF or you'll find a special pattern, and then you'll notice, one of those factors can also be factored again. And so these are some examples that you might see. It's just going to take a lot of practice. But when I look at this first one here, the first thing I notice is they all have a bunch of things in common. They all have an x. They all have a 3. So let's start by taking out a 3x. Okay, so that's going to be the first thing we're going to do. Now, they don't all have y's. I'm not going to worry about that, but I am going to take out a 3x. So if I take a 3x out of 3x squared, I get an x. If I take a 3x out of 6xy, I get a plus 2y. And then 3x out of minus 9, that'll be 3. I've got an x, and I need a y squared. Now, I'm looking at this, and it doesn't look like I can do anything more. So at this point, it is factored completely. Okay, you don't have everything with the y's, but sometimes you just get lucky. You go, okay, well, that's it. I can't do anything more. Second example, when I look at these, I see two terms, and I notice this is one of those special patterns. But even before that special pattern, they both have a z. Okay, they both have 3's. So I'm going to try to take out anything common first. And since they have 3z, I'm going to take them both out of there. And if I take out a 3 and a z, that leaves an a squared left. If I take out a 3 and a z, that gives me minus 9. So this is one of those things where I started with greatest common factor, right there. But I now notice that this factor that's left, this is the difference of squares. So this is a times a, and this is 3 times 3. It's always going to factor the same as that other pattern we went over, the difference of squares. It's going to be a plus 3 times a minus 3. I did a whole other video on that. Actually, you were introduced to that in Algebra 1, and we've gone over it a few times. You may need to remind yourself again. And a lot of this is just recognizing the patterns, but those clearly are 3 unfactorable parts. Okay, number 3, I look at n to the 4th minus 81. They don't have anything in common. So then I think, okay, 2 terms. Which of these 2 terms does it look just like? I see a squared thing and I see a squared thing. When I look at it, that's what I see. So this is n squared times n squared, and this is 9 times 9. So that pattern again is going to be just like this. It's going to factor into n squared plus 9 times n squared minus 9. Now this cannot be factored anymore. There's nothing to do with it, but this one can be, because this again is the difference of squares. So just like here, it's going to be very similar. So it's n squared plus 9 times n plus 3 times n minus 3. Again, you just have to recognize the pattern, which is why we will practice it together in class. It's just something that the more you do, the more you will recognize. Fourth example, when I look at this, I see 4 terms. Now, so far, I did an overview video, I did a 2-term video, I did a 4-term video, and then this is the 4.4 examples. So you should notice I've got 4 terms. That's going to be factoring by grouping. So what I'm going to do as far as I group is I'm going to do just the easiest way is to just start with the first 2 and see what you can take out. So I see that they both have a b squared in common. That's going to be b minus 3, because b squared times b will give me b cubed, and b squared times minus 3 will give me 3b squared. And then I go on to the next 2 terms. The only thing I see that they have in common is a 4. And since this is a minus, I'm going to take out a minus 4. So minus 4 times b is going to give me minus 4b. And then minus 4 times minus 3 will give me a positive 12. So this is good luck. I see that these are both b minus 3 common factors. That means that this and this can come down together and can be written b squared minus 4 from there times b minus 3. And then you ask yourself, okay, are any of these special patterns? Because if they aren't, I'm done. But look, you have the difference of squares. So this one, again, can be factored as b plus 2 times b minus 2. And then this one is b minus 3. If this were a polynomial that we started with 4 different terms, we factored it twice, which means completely, and I now have 3 single terms that hopefully hint we're going to be finding our roots by in the next section. Okay, again, that just means factor completely. Do as much as you can each time. So usually 2 times, but sometimes 3. So the last kind of problem I'd like you to have in your notes is this: show that this binomial, x minus 2, is a factor of this big long one. And what it's asking you to show is, can you divide this into this and get a remainder of 0? That is showing that it is a factor. Now, there's a number of different ways you can do this, but you could either factor this down and see and show that that's one of them, or you could divide this small factor into the big one and see if you get a remainder of 0. And then when you do that, you have the choice of either long division or synthetic division. Those 3 things are all valid. Personally, because this is a single exponent and coefficient, synthetic will work here. I've got an x to the 3 power, an x to the 2, an x to the 1, and a constant. So really, I could just set it up pretty quickly. If x minus 2 is my binomial factor that I want to check, then 2 is a, so that comes from there. These coefficients in order are 1, 7, 2, and negative 40. So if I do this synthetic division and I end up with a remainder of 0, that is showing that this is a factor of the larger one. That's it. So I bring my 1 down. 2 times 1 goes here. Combine those. 2 times 9 goes here. Combine those. 2 times 20 goes here. Combine those. Yay! Because I have a remainder of 0, I have just shown that x minus 2 is a factor of that big polynomial. And I'm done with examples for now. We're going to go ahead and, like I said, keep going in class. You should be able to do big ideas now. Yay.